Zombie apocalypse.
I'm Dr. Emily Grossman. Welcome to Cinema Science, the show where we check out some favourite films to see if the science they contain is up to scratch. This week, we're looking at explosions in space. If you're a fan of science fiction or space movies, you'll have probably caught yourself looking forward to that epic moment in movies such as Star Wars or Ender's Game, where the enemy spacecraft is finally shot down, exploding into a massive fireball with an enormous boom and sending debris flying out in all directions. On Earth, explosions normally happen when a material is subjected to a huge amount of heat or pressure. The heat and pressure build up until there's a sudden outburst. If the gas is flammable, it can act as a fuel, and the heat can be enough to cause it to burst into flames, generating a massive fireball, with the accompanying pressure wave giving rise to an enormous boom. Now, if you remember your fire triangle from school, you'll be familiar with the fact that fire needs 3 ingredients: fuel, heat, and oxygen. And so space is a vacuum, a nearly total absence of any gas molecules, including that all-important third ingredient, oxygen. In the absence of oxygen, fuels simply cannot burn, so a fireball in space should be impossible. Another problem is the big boom. When sound energy passes through a solid, liquid or gas, it relies on the vibrations of the particles making up the medium. The lack of air particles in space means that sound waves simply can't travel, so any explosion would be completely silent. The lack of air particles in space means that sound waves simply can't travel. The lack of air particles in space means that sound waves simply can't travel. The lack of air particles in space means that sound waves simply can't travel.
Imagine you're an astronaut flying behind the moon and you hear a strange sound, an outer space type music kind of sound. What would you think? What would you do? And back in May of 1969, that's the situation the Apollo 10 crew found themselves in.
That music even sounds outer spacey, doesn't it? Do you hear that whistling sound?
That clip appears in an upcoming episode of the Science Channel show NASA's Unexplained Files. Since there's no radio signal on the far side of the moon, the crew wasn't able to talk to Mission Control at the time. They opted not to tell NASA when they returned to Earth. But transcripts from the incident emerged in 2008, and some of the audio appears in the upcoming episode.
The lack of air particles in space means that sound waves simply can't travel, so any explosion would be completely silent. The lack of air particles in space means that sound waves simply can't travel, so any explosion would be completely silent.
In fact, one of the things, that's what this was supposed to demonstrate, that without air you don't hear sound. And so the idea is you get a doorbell in here and then pull a vacuum on it. You start the doorbell ringing and then evacuate the bell jar, and then the sound disappears. Okay, and then
All right, move closer. Just plan the next 2 minutes. Wherever. You won't be able to get it. So we can put a sheet under it.
I'll just pump this for a minute and then I'll close this off and shut off the motor. Okay. Nothing, right? Can't hear the music.
Oh my God!
The tapes contain recordings of strange, otherworldly music coming through the Apollo module's radio. The conversations that follow the sound makes it clear they are unlike anything the astronauts have ever heard.
In space, no one can hear you scream. In space, no one can hear you scream.
Here's an interesting story. New audio tapes from the Apollo 10 mission reveal an eerie experience on the dark side of the moon. Nearly 50 years after the mission, the audio captures when astronauts reported hearing space music. Listen.
That is music even sounds outer spacey, doesn't it? Do you hear that whistling sound?
So space is a vacuum. So space is a vacuum. The lack of air particles in space means that sound waves simply can't travel. The lack of air particles in space means that sound waves simply can't travel. So any explosion would be completely silent. So any explosion would be completely silent.
You could spend hours a day for months looking out the window and never get tired of it. You could never learn all of the Earth, and the Earth is very dynamic. Things change with seasons. There's always lightning storms going on somewhere on the Earth at night, and you can never fail to see these lightning flashes.
It lights up a whole circle of clouds around it, and that seems to set off another flash a few hundred miles away somewhere else. So you get a sort of drrrr of lightning, and then another bit somewhere else.
In space, no one can hear you scream. In space, no one can hear you scream.
Somewhere else. So you get a sort of drrrr of lightning, and then another bit somewhere else. Somewhere else. So you get a sort of drrrr of lightning, and then another bit somewhere else.
The lack of air particles in space means that sound waves simply can't travel. The lack of air particles in space means that sound waves simply can't travel.
The conversations that follow the sound makes it clear they are unlike anything the astronauts have ever heard.
All of us are wired to appreciate natural beauty, if you will, and anybody, at any time in history, any culture, if you look at an ocean or a mountain or a beautiful forest scene, everybody appreciates that. I mean, it hits us fairly deep. We're wired that way. And when you see your planet that way, in its sum total from space, you know, all those senses kind of get overwhelmed.
First saw planet Earth from space, and still during the launch, outside the atmosphere of Earth, and we were over the Pacific Ocean and just looking at that gorgeous blue, dotted with white clouds and the black of space.
This impossibly blue planet in this impossibly black sky just kind of hanging out there. It is really, really breathtaking.
Even though you've seen the Earth through movies, pictures, when you look at the Earth with your own eyes, changing very fast at the speed of 8 kilometers per second, what you see is beautiful. You have tears in your eyes, even if you are a tough person, you can't avoid becoming a child again. And we wish all humankind could experience this view of Earth.
It is this perpetual, dynamic picture show that again, you never get tired. Even 6 months into the flight, if you pass by a window, it's like a magnet that draws you to it. You want to pick up a camera and take pictures of it.
As we fly around the Earth, every 92 minutes, the Earth has twisted around by about 13 degrees underneath us. So the next time you fly another orbit,